and welcome to this month's Virtual Brew. We're going to talk about the MicroMax interrupter and then go into the different CI survey modes. So we're going to look at some of the hardware of the MicroMax, mainly the MicroMax 360, but the 300 is included in this as well. MicroMax settings, as far as universal settings, as far as getting your interruption set up for your surveys. And then we'll look at close interval survey methods. There's three survey methods that you use with interruption. So the first thing I talked about is our MicroMax interrupters. We currently have the GPS 300. This does not have a relay attached. This is used for an external relay, to drive an external relay. It could be solid state or it could be mercury, either one. The GPS 360 has a battery built into it, and this can provide up to 60 hours of interruption. And it also has an attached solid state relay that can interrupt up to 100 amps, and can be used with an external relay as well. We'll talk a little bit more about that after a bit. So the first thing that you're going to need to do is get your GPS. So this will come with a GPS antenna. It's magnetic. So you should be able to set that on the top of the rectifier, because the GPS is where we get our pulse per second. And that pulse per second is read by every other interrupter out there. It's also read by the field data collector in the DVM, so that everything can line up and you're synced when you're ready to do your interrupted survey. So hooking up either the 300 or the 360, you will have a pigtail with two alligator clamps on there. These can be hooked up to the AC taps on the rectifier. As long as you find between any two of the taps, if you can find 8 to 42 volts AC, you can hook that up, and that will power either one of the MicroMax interrupters. If you have a DC source and you're coming off of a DC source, could be a battery, you can do the same thing, but there we're looking for 10 to 60 volts DC. If you need to power an external relay at the end of this pigtail that also has the input for the power, there is an output that you can run an external relay. It could be solid state, could be mercury, either way. That output is 10 to 14 volts DC to drive the relay open and close. Now, if you are going to power an external relay with the GPS 360, you'll need to make sure that it's powered up as far as you are connected to the taps or you're connected to a DC source. If you're running it strictly off the battery, you cannot power an external relay if it's run just off the battery. The two different relays that we supply, and these are the main relays that are out there. You have a mercury relay. We have a 60 or a 100 amp. This is a mechanical relay. Of course, it has to be installed vertically or it will not work. There is mercury inside there, and it's a little electromagnet that will open and close those contacts. Now, if you are using a mercury relay, These are not recommended for cycles shorter than 3 seconds on, 1 second off. Over time, that mercury relay can degrade. You can get some chatter, some noise in there. Our current solid state relay is the REL 2510. This can interrupt even low voltage rectifiers, and it supports a fast cycle. So you can do sub-second, you can do 0.8, 0.2, 0.7, 0.3 cycle on there. You can do a 1.5 half for your on-off as well. Now, when you first power up the MicroMax on the screen, you're going to see some data, some info for you. The first thing is the antenna status. This is going to be open, short, or okay. So if you don't have an antenna hooked up there, it's going to be open. If there's a kink in that wire that maybe a cow has chewed through, in that coax, you could have a shorted antenna, and then you also have an antenna status of okay, which means everything's good. You also have the satellite status. If it says ACQ sat, that means it's waiting to get satellites. Once you have satellites, it will show you as 3D fix, and you see that it'll have the number of satellites that it's currently seeing. You also have a unit status, and down here at the bottom, you could have check antenna if it's opened or short. It'll give you your UTC setting, so this would be your time zone. If it's waiting for that 3D fix, you have good antenna, it's waiting for the 3D fix. That's what it will show, and it can also show whether it's waiting for its leap second to get updated. Some of the things on the output parameters. So these are universal parameters on here. This is the first thing you're going to set, and once you set these, you leave them. They're independent. They cover all of the interruption cycles. So if we go to option and output parameters, you can do your switch. So in this case, normally closed. If you use the wrench to change that, it just toggles between normally open and normally closed. Most of them should be normally closed. Your cycle begins with, in this case, it's on off. If your cycle begins with off, then you change that, it'll toggle over to off on. You have your UTC offset. So this is where you'll set what time zone you're in. That's pretty simple. And we also have a zero crossing. This helps prevent some of the breakdown that can be caused by transients, by induction. We'll talk about that here on the next slide. And then number 8 is factory default. So set everything back to the factory default. Zero crossing just means that when the AC crosses over the zero line, that's when it's going to either open up or close the relay. What this does is this helps dissipate the power on there quite a bit when it's at that zero crossing. So you don't have all that inductance in there when it does its switching. Now, I will say that, this could cause the delay about plus or minus 4 milliseconds. If it's somewhere in here, it's going to wait till it gets to that zero crossing. It's about 4 milliseconds. If you're looking at a total cycle of about 16 milliseconds for the full cycle at 60 hertz. And this will help protect the relay and components. Some of the icons up at the top will let you know if the power is connected. If you have a 3D fix, the number of satellites, and if you have the GPS 360, it will give you a battery status as well. So programming, we're going to select one on the programming for interrupt. We'll select which program we want here in this case, and maybe select 3. 3 is defaulted to 3 on, 1 off. 4 is defaulted to 4 on, 1 off. Now these can be changed. All you have to do is change them, and you can set whatever you want for that on-off cycle. You also have options here. You can do continuous, you can do stop-start. In this case, we have stop-start. It's going to start at 6 a.m. on March 2nd, and it will stop at 6 p.m. on March 10th. So every day it's going to do that in between those 2 dates, and then it will shut off, and then your CP system will just be constantly on. So verifying interruption in the field data collector, of course, we'll go to the DVM. I'm sure you've seen this slide multiple times. This is extremely important. When you are going to start your interrupted survey, this is the first place that you want to go. So make sure that you're starting here and you're getting your everything in sync, all your settings correct, so that you are getting your accurate on and off readings. So looking at the waveform inside of the DVM, of course, the gray area is the on portion of the cycle. The white area is the off portion of the cycle. Up at the top and the bottom, there are tick marks. Each one of those is 1 second. In this case, we are looking at a total of 8 seconds. And we are doing a 1, 2, 3 on and 1 off. What I like to do is if I'm doing, say, 3 on, 1 off, I'll set that to 8 so I see 2 full cycles on my screen as it goes by. And of course, we're going to set up our on setup, which is, in this case, is 100 milliseconds before the on to off transition. And we're setting our off delay to 125 milliseconds after our on to off transition. And that's where we're going to record our instant off reading. And then our cycle begins with the little shark fin at the bottom. In this case, our cycle begins with on, because it's starting in the on portion of the cycle. Now, the first method is we'll look at is on-off GPS sync. So GPS sync is what the majority of surveys are run as. This will sync up with the satellite. So that satellite timing and that and the MicroMax and the field data collector, the DVM on that are all synced up on that same time. So you're going to set up all your interruption. You're going to get ready to go. All your cycle begins with, and everything should be synced up. And in GPS sync, if you look at your readings as you're taking them, this is what you're going to see. You're going to see an on reading in the first column and an off reading in the next column. And to note on this, if I'm doing a 3-in-1 cycle, I will get a new on-off pair every 4 seconds, because it's going to get an on-off pair, and then it's going to wait again for that next cycle and get an on-off pair. So you'll notice in here we have a change here in our off reading, and then we have a change here in our on reading. So these are going to be the same for, in this case, 4 seconds. If you're doing a 4-in-1, of course, it's going to be 5 seconds. If you're doing 0.8, 0.2, it's going to be every second you're going to get a new reading. Next thing to look at is GPS real time. GPS real time The settings are slightly different. And we have an extra GPS real-time setup time on here. This is used for longer cycles, 3-in-1, 4-in-1. If you're doing an 8-second on, 2-second off, you're doing an 8-and-2 for any type of reason. Of course, you're not going to get a new on-off pair, except for every 10 seconds on there. So every 10 seconds, you will get that new on-off pair. So to look at this, what we're doing in here is we have our real-time on delay. What that is after the off to on transition, that's where we're going to set one of the sides of our window. We also have a real-time off delay. So in this case, 100 milliseconds into that off portion of the cycle is where I'm setting 1/2 of my window. Now we also have a real-time setup. So this is each time before both of the transitions, how many milliseconds before those transitions am I going to set the other side of my window? What I'm doing here is I'm creating a window inside that has the transitions inside from on to off and off to on. And if a reading is triggered inside of that window, it knows that it's in transition and it's not going to record that reading. It's going to record the last known good reading. So if I do this in here, anytime in here in this transition from on to off, it's going to record this last good reading. Same here. If I record any time in this reading between the transition from off to on, it's going to record this reading. As readings are triggered, anytime in this cycle, it's just going to give you that reading. So it'll give me my on, and then it's going to give me offs, and then it's going to give me ons. And this is how it'll look when you are running that survey. So this, you'll see I have an on reading, I have off, off, on, off, off. And each of these readings are different. So these are not matched on-off pairs. These are live readings as they are triggered. So I'm triggering it in the on portion of the cycle, and I'm triggering it in the off portion of the cycle.
Hey, Lon, we have a couple of questions.
Yes.
Cole mentioned, hey, how many people today are using MicroMax interrupter? So if you are, I suggest you can drop a yes in the chat. And then we had a question from Casey. Is that to keep us from recording spikes? And then we have one more question after that as well.
So as far as the GPS real time, what that's keeping you from doing is recording anything that's in a transition. So if I record a reading right here in the middle of the transition, I know that reading is incorrect because it's in the middle of a transition. So in this case, it could be around, 1 volt if I record it right here, and that's not a good on or off. That's not a true on or an off. This is just keeping you from recording anything inside of that transition. Now, as far as spikes that you're talking about anodic spikes, I'm sure. Let me back up here on this. This is where in GPS sync, you are going to record. If I had an anodic spike here, I'm just going to move this off delay out until I'm past that anodic spike. And then I will get my true instant off reading, my true polarized potential. Is there another question?
The other question was from Charles, and he asked, what are the delays for the previous GPS mode?
The previous GPS mode, GPS sync, is that what you're talking about, Charles? Yes.
Yeah,
Okay.
he said.
So the on setup, if you think of setup is anything before something happens. So in this case, I'm 100 milliseconds before that on to off transition. And then any type of delay. So this is 125 milliseconds after the on to off transition. So that is where that delay comes from. As far as the GPS real time, both your on and your off are delays, and your real time setup is a setup, so it's before that transition. I hope that helps. Another thing to talk about is high-low. So there's also a method called high-low. High-low is used if you don't have GPS or if you've lost GPS. So you cannot get a synced reading. What it does is it takes up the total, looks at all of the samples of your total cycle. So in this case, I'm talking about if I'm 4 and 1, I have 300 readings because I'm reading at 60 hertz, which is 60 times per second. It takes those 300 readings and it sorts those from positive and negative. Then I have my delay set up for so many milliseconds. What that's going to do is that's going to remove so many readings. So for every 100 milliseconds, it's going to remove 6 readings. So this is a good way to remove the spikes if I do not have GPS sync, because I can eliminate all of those more positive readings on that anodic spike. Now, something to be aware of here is the fact that if, let me bring this back up here, that in high-low, it's going to assume that your more negative readings are your on readings. So if you have an inversion, it's going to mask that. This can also mask any type of interference. So interference, it's going to take all of those readings, sort them out, so it doesn't know about any type of interference. So when we are looking at our high-low, we just look at the delays. And this is how that works. I have an on portion or an off portion and an on portion. If I set, say, my off delay to 500 milliseconds, that's going to eliminate 30 of the more positive, electropositive readings. And that's going to record my off reading at this point right here.